Hello everyone, welcome to the another exciting tutorial of this GIS software video series. Today we're gonna see another project which is called the project 2. So in this project we're gonna see many analysis and many geo processing tools to use. So let's jump on it. So this is the project 2 we can see. Uh, so here given special data set which is for Rajshahi City Corporation, which include education facilities and ward boundaries. So I in ArcMap I have added the data in here, and we can see the ward boundary and the educational facilities here. So our first question is that prepare RCC boundary using special data of ward boundaries. So what does this question mean? It means that we have given a ward boundary, so we have to make it a one file. So what we're gonna do, we are gonna do the from geoprocessing tool, we are gonna do the dissolve to get the boundary. So we dissolve it. Here we input features the RCC word band, and we are gonna press the output to the output. We're gonna name it RCC resolve this. Okay. Now we hit OK. So we can see that from the attribute table the RCC word boundary is made. We're gonna give it a hollow, no fill, and make it red boundary. So this is the ward boundary, and the education facilities. From the education facilities feature, from the attribute we can see that there are many house owner name, land area, land use, and their school, which is probably most of them are, all of them are primary school. So now we have to go to the question again, and our first question is done. The second question is taking 500 buffer as standard service area of primary school, calculate. So number A question is calculate percentage of only served area, over served area, and unserved area within the RCC area. So first we have to take the 500-meter buffer as standard service of primary school. So we go to the here, go to the ArcMap, and we have to take the 500 buffer to each of these school. So we are gonna go to the geoprocessing tool and hit buffer. In input feature, we are going to take the education facilities and we're going to save it here, which is we're going to call school buffer 500-meter, and save. And here we will give 500 linear unit meter, and that's it. Okay. So you can see that the 500-meter buffer from each school has been selected. Now we are going to jump on the next task. So next task is that we have to calculate the served area, over served area, and unserved area. So first we have to see that the served area is in this 500 meter, and the unserved area is this white surface which is not in the 500-meter buffer, and the overserved area is the included intersection of this buffer. So if we identify from this tool, we can identify any feature. So we can tick it, and here we can see that 4 primary school is here. So it is overlap. It is in this area 4 primary school give their service, so it is overserved. So again we're gonna select this intersection, and we can see that there are 5 schools here overserved. So what we can do, so we have to now calculate the intersect between this 500-meter buffer. So how we can do that? We go to geoprocessing tool and hit intersect. We input the feature, which is this one, and we're gonna save it here, which is I'm gonna buffer intersect. We hit save. Okay, so we can see that the intersect, the over sub area are selected. Now we have to make it a one shape, so we are going to dissolve it. Intersect, we're going to save it, dissolve. Okay, now we hit OK, and here you can see that the over sub area intersect option are dissolved. And if you see the attribute table, you can see one polygon. So now what we can do, we have to again, if we close this one and this one, you can see that the buffer attribute table, school buffer 500-meter, here are many, here are 149 polygons. So we have to make it one polygon. How we can do that? We have to do it by dissolve. So we dissolve again, and in this case we're gonna put it the school buffer 500-meter and 500-meter. We name it this. Save, and okay. So here it is. Now it has been dissolved. Now what we'll do, how we can find the overserved area in this category. Now we have to introduce you to another tool, from the toolbox, which we can identify overserved area in a served area. So the tool in this toolbox, we will go to the data management tool. Sorry, we'll go to the analysis tool, go to overlay, and here we can see the identity. We hit it. Here we have to put input feature and identity feature. In input feature, we will input the area in which we will identify some feature. So we are going to input the served area, which is school buffer 500 dissolve. And in identity feature, what will we identify? So we are going to identify the overserved of area, which is this intersect dissolve option. So we hit this feature and we're going to save it. We'll name it served over served. We save and we click OK. So if you go to it attribute table, we can see that there are made two polygon, which is, if we select one, we can see that only the whole polygon are selected, which is indicates that it is the served area. And if we select this one, we'll only see the only intersect option, which is the our overserved area. So the overserved area and the served area are identified. Now we have to identify the unserved area. So how we can do that? As you can see that the unserved area is this empty area from the buffer distance. So but it is in the ward area, it is in the ward. So how we can identify it? We have identify this one with the RCC dissolve. So we're gonna hit again, go to the identify tool, and in this case we input feature will be the RCC dissolve, and the identify tool will be the served and overserved. We're gonna save it here. Now it will be called served overserved, served. We're gonna hit save and hit OK. So if you close this one, and this one, if you go to its attribute table, we can see the three different polygon. If you select this one, it will select the outer outskirts of the served area, which is the unserved area. The second one will be selected the served area, and the third one will be selected the only the intersect area, which is over served area. So we're gonna add a new field to give status. It will be a text. Okay. Now we have to start editing. We're gonna name it. This one will be the served. This one will be the served, and the last one will be over served. Stop correcting and hit the save. So this one, this has been categorized. To categorize it, you go to properties and go to symbology category. Here will value field will be the status which you created. We'll add all values and we'll take on this one, delete this one, and we're gonna give it a good color. So we're gonna hit apply. It has been categorized, and we're gonna give it a label. Label will be the status and apply. But it is been placement properties. We're gonna delete the duplicates to see it more good way. So as you can see, the unserved area, overserved area, and served area has been identified. Now we have to get calculate the area of this served, overserved, and unserved area. So you go to again attribute table, and we're gonna add another field which is name area. We're gonna give it a double. We're gonna hit OK. Again we add field, and it will be area percent. It will also the area will be calculate geometry, and we'll calculate the area of this served versus unserved area. We'll maintain the square meters. Hit OK. Now yes, the area has been calculated, so we have to, from statistic, we have to copy the sum to get the percentage. We'll copy and go to sum and field calculator. Here we'll select the area divided by its sum into 100. Hit OK. Now the percentage has been created. So our first question was calculate the percentage of this area served over unserved area, which has been calculated here. So our first question is done. Now if we go to the second question, what we'll see? The second question told us that calculate percentage of served over unserved area within the RCC area against each ward with reference to total RCC area. So we have now to consider the ward basis to calculate the served over unserved area. So let's go to ArcMap, and here in which feature we have the ward attribute. In this RCC ward boundary, we have the ward attribute. We open attribute table. Here we can see that the ward has there are 30 ward. So we have to merge it to with served over answer area to get the answer. So how we can do that? We have to intersect these two options. From geoprocessing, we go to intersect, and in this feature we will give served over served, unserved, and the RCC word boundary, and we will save. We'll call it word status. We hit save and OK. So in this word status, if you go to its attribute table, we're gonna see the of the area of the word. Now if we go, now we have to calculate the each of the area. We're gonna add a new field which is called the area square meter. We'll type the double, and again we will add field which is called area percentage. We calculate this geometry again in square meter also. We hit OK. Now the area has been calculated, and we will go again statistics to copy the sum. Copy, and again go to field calculator. In this area percentage, we will bracket area square meter divided by the sum, and into 100. We hit OK. Now the percentage has been created. Now what we will do, we got the area and the area percentage. Now we have to copy this data and take it to the Excel file to further analysis. We'll select all data and copy. We go to Excel and paste the data. Now from insert, we'll go to pivot table. Here you can see we'll existing and select a folder. Hit OK. Now the square area per square will be in the values, and the word status will be in column, and the word ID, which is word I, will be in row. So here we can see that the oversub unserved area has area percentage has been calculated on the basis of this 30 words, and the sum is 100. So this calculation is correct. So our second question has been completed. Now we'll see the third question. The third question tells us the similar to the second question. It only says the served area, over served area, and served area percentage against each word, but this time reference will be the word area. In question B, the reference was total RCC area, but in this time the reference will be the word area. So what does it mean? In the in B question, RCC total area was sum was 100 equals to the RCC area, but in this case each word will be 100 in percentage. So let's do it. If we close this again, now we have to where we can get now we have to divide this area we have calculated by the word area, which is here, word area. So if we again add field which is called area word. Okay, now field calculator, and we are gonna bracket, and this area square kilometer will be divided by the word area, which is the area 1, bracket close, and it will be multiplied by 100. We hit OK. So the word area on reference to the word area has been calculated. Now we have to again take it to the Excel file. We have to select all of them and copy. Again, go to Excel and another sheet, and paste it, and insert pivot table. Again, in this case, the word area will be in area word will be the in values, and the word will be in rows, and the status will be in column. So you can see that the grand total of every served, overserved and unserved area in a word is 100. So this is the difference between reference to word area and reference to RCC word. So the third question has been solved. So let's see the fourth question. So number 4 question tells us that calculate the percentage of population for underserved area, overserved area and unserved area within the RCC area. So this time we have to calculate the population for each of this area. So how we can get the population? If you go to the arc map and see the RCC ward attribute table, you can see difference air population, which is 2000, 1991, 2001, 2031, 2020. So if you calculate a year's population from here, we can get the this served area, unserved areas population. But we can't calculate population by like area. So how we can do this? We have to get measure the population density for each of this word. So if you multiply this population density with the area we calculated, we can get the population of those each area. So we are going to add a new field which will be called population density, and it will be given double, and we hit OK. We're gonna calculate, and here we will calculate 2020's population density. So we're gonna this one and divided by the word area, and we hit OK. So the population density has been calculated. Now what will we do? We have to get this status to merge with this population density. So we are gonna again intersect these two again. So go to geoprocessing and go to intersect this file and RCC word boundary. We're gonna save it. This time we will call it pop density, pop status. Hit save, and it has been created. And if you go to pop status and its attribute table, we can see that the population density has been added, but the area of the word has been taken. And this time the area, we have to update this area because the served area and unserved area are divided into many small areas. So you have to update this. Go to calculate geometry and square meter, we hit OK, and yes, the area has been updated. Now for this each area we have calculated, we have to calculate the population. So we'll add a new field which we will call population, and it will be a long integer, population 2020. OK. We will go to field calculator, and we will area will multiply by population density. Okay. The population has been calculated. Now we have to calculate the percentage of it. We will add another field, population percentage. It will be double, and hit OK. Population percentage. We again go to field calc. First we have to take the sum of this population, field calculator, bracket, population, and then divided by the sum into 100. Okay, a percentage has been calculated. Now what will we do? We will simply take this to the Excel file, we select all and copy, and again go to Excel file and create another sheet. We'll paste it here and insert from pivot table. We'll go here and we are gonna create a pivot table. We'll put the population percentage in values, and the status, where it is, the status in rows. So that's how we can get the served, overserved and unserved areas population percentage, which is 100%, and it is the answer of the D. If you have to calculate the E question, which is the calculate the percentage of population of unserved area, overserved area and unserved area against eastward with reference to RCC area, we have to go to again go to the ArcMap. We don't have to go to the ArcMap now. We will just go to the Excel and again create a sheet. We go to ArcMap and again copy this data, which is selected again, and paste it again. Insert pivot table. This time we'll drag down the population percentage to the values and the ward area to the rows and the status in the column. So we got the served, overserved, unserved area of each of these 30 ward, and we have got their population percentage, which is sum is 100%. So this is the answer of the E question. Now we have to calculate the F question, calculate the percentage of population of unserved area. In this time the reference is the ward area, similar to the question of number C, but in this case we have to calculate the population. So we will go to the ArcMap again. Now we have to add another field which will be called population ward. Population ward, and it will be double, and hit OK. This time we'll go to field calculator, hit OK. Now what we will do, we go to bracket, and this time the population we calculated to 2022 will be divided by the population 22 we calculated divided by the ward population, which is P 2020, and we will close the bracket and we will multiply it into 100. We hit OK. So it has been calculated. Now we again copy this and copy and go to Excel again. We're gonna create another sheet and we paste it here. Again, create a pivot table. Now we'll drag this population ward to the values this time, and the ward will be in rows and the status will be in column. So as you can see that the reference ward the overserved, unserved and served area has been calculated, which everything sum is 100, every word sum is 100. So it is the answer of this F question, which is the reference is the word area. So our last question will be this G. This last question tells us that calculate the percentage of population within overserved area based on the availability of services like double serve, triple serve, and like that. So now we have to deal with the overserved area. In this case, we have to calculate the overserved areas primary school served, double serve, triple serve, or more than 3 or 4 something. So we'll again go to the arc map, and if we select this one and this one, in this word the overserved area is this buffer intersect option. So in this intersect option there are many overlap. So in this overlap they may be 2 or 3. From this identity tool we can, if we select this one, there are 1, 2, 3, 4, 5 school. If we select this one, there are 5 school. If we select this one, there are 2 school are overlap. So we have to calculate in which area how many schools have been overlapped. So how we can do that? First we have to identify this intersect to feature in the basis of this RCC dissolve. So we again go to the art toolbox and hit identity, and we input features will be the RCC dissolve, and the identity feature will be this intersect, and this time it will intersect identity. Hit save and hit OK. So this time the it has been intersect. If we go to this new shapefiles attribute table, we will see that every area has been given here. So this time we have to calculate the area. We'll add a field and area, and we hit OK. So we'll go to area and go to calculate geometry, and we're going to calculate in square meter. We hit OK. Yes, variable yes. So we can see that area has been calculated, but if we see in more detail that there are many area which has been 0 or less than 10, but it is impossible for a man to get service in less than 10 meter area. So we have to delete this, and also we have to delete first polygon, because if you select this first polygon we will see that it is the unserved area which is not in this part. So we'll have to delete it. How we can delete it? We go to its properties and go to definition query and go query builder, and first we'll FID is not equal to 0, and the area must be more than 9, because 10 meter above 10 meter people can get service. So we hit OK, apply, and OK. So this has been selected. Now we'll go to its attribute table and copy this all data and copy selected. Again you go to Excel and create a new sheet. We're gonna paste it. Again you go to insert and go to pivot table. In this time we'll calculate the area of area count. So we will give this area to the row, and again we will give this area to the values, but this time we will not calculate the sum of this area, we'll calculate the count of this area. So we'll go to value field setting and we'll select count and hit OK. So this 10 meter area is counted 14 times in this area. So we'll copy this copy. We're gonna go to another sheet and hit paste values. So if we, the last one, we don't need the grand total. We'll select all of this and name it data to be joined, and this file will be saved as Excel, and but we'll save it in XLS file, which is more suitable to the ArcGIS desktop software. We'll save it and we'll continue. So it has been saved. Now again we go to this, and if we see it, if we now we have to dissolve this, dissolve this intersect over sub area option to get it done. So we'll go to geoprocessing and hit dissolve. First we have to clear the selected and go to dissolve, and we will take this one and we'll save it. Dissolve, save, but this time the dissolve field will be selected in area, so we'll hit OK. So if we go to its attribute table, you can see that only area has been selected. Now we will join the XLS file to this one to count the area. So we'll go to join, and in this we will select area field, and this file option will select the file we saved here, data to be joined, and we hit add. We'll join the row table to this area. We'll hit OK. If you go to this attribute table now, we'll see that the file has been joined more perfectly, which is this one, and the count area has been selected. Now what we will do, how we can see the area option. So if we go to its properties, we'll go to symbology and go to categories, and the count of area value field, and we will add all the values to here. Cross this one, and we apply. Here we can see the count of this area, how many times it has been overlapped, and we will add the level, which is the count of area level field, and we apply and OK. So as you can see, every area has been counted by this option. So we can see that if we identify this area, if we select this one 5-1, we can see that this area has been overlapped 5 times, this area has been overlapped 4 times. So this the last question has been solved. So that's how can solve these problems by this geoprocessing tool. So that's for all today. Thank you everyone. See you next time.